Hey guys, what's up? So I've had a few questions from one of my viewers regarding the scrolling of more advanced shapes, as my last video on this only really covered how to scroll really basic shapes like boxes mainly, or any symmetrical shape pretty much. Um, which can be generated with a pure for loop. Uh, while any shape can actually be made with just a for loop, some shapes might be more inconvenient to make with for loops than to just assign what LEDs you want to light up manually. And in this video I'm going to show how to scroll such shapes, which are, well, more advanced than just basic boxes. So I've written some code here and I'm going to run you through it. There we go, now you can see my pointer as well. So basically, first and foremost, this is the same clean function as last time. It just cleans all the LEDs so that there is no residue from previous iterations of the effect or any previous effects either. This is the function which does all the scrolling. I'll walk through that later. This is a modified version of my old effect with the beating hearts. I'm using that mainly for demonstration purposes. Of course you could use any shape. I was just too lazy to come up with anything, so I repurposed my old code. It works pretty much the same as before, with a few minor changes, and I'll walk you through them as well. And these two defines here just make my life a bit easier. They determine whether the effect should be brighter or dimmer. So I'll just walk through the heart first. Basically, this indicates what kind of change in brightness the shape should have. So if it should get dimmer or if it should get brighter. This right here determines the brightness of the or the index of the brightness of the shape. So these are the actual brightness levels which are used. So there are 6 of these, which is why the highest value here is 5, because arrays go from 0 to 5 if they are 6 elements long. These two arrays right here, they define the LEDs in the x-axis and in the y-axis, which should be used to, which should be lit up basically from the start. And I've gotten these from this nifty, scheme, I suppose. Don't remember where I found it. I think the GitHub for the original GitHub project for the RGB Shades. I think, I'm not sure, I could post them to my GitHub. It's pretty good to have. This is just an integer telling how many LEDs are being lit up by the effect. In this case it's 22, so it's the amount of elements in each of these two arrays right here. So the actual effect, first and foremost, it initializes everything. I have a nice slow delay here so that the effects can actually be seen and not just flashing by really fast. It cleans every iteration. If change, this variable up here, is set to be brighter, then the brightness variable is increased, otherwise it's decreased. If brightness is higher than or equal to 5, change is changed to become dimmer, so that the effect will thusly be, well, dimmer every iteration. And if it is below 0 or equal to 0, it gets brighter again. And then I have the for loop, which just runs through the number of LEDs, in this case 22, as I said, calculates each individual LED number from this scheme right here. So if I want 2, 1, x-axis 2 and y-axis 1, I get 27. That's what that calculates. It gets that ID, that index of the current LED, and then it sets a value, which is in this case red with some brightness defined by this array up here. And then it calls the scroller function. Now the scroller function is where all the magic happens. It takes an offset in x-axis, an offset in the y-axis, and then it takes a pointer to an array of LEDs in the x-axis and the same for the y-axis. And then it takes the length of the array. And these two arrays have to be the same length, otherwise this will not work. And most likely they will be the same length because, well, you know, you can't have an x-axis without having a y-axis, so there should be an equal amount of elements in each of those arrays. So basically what I'm doing is just running this through a for loop. So each place, each index in each of these two arrays are changed to have the same value plus the x offset, and that is modulo 16 because we have 16 positions in the x-axis, or 16 LEDs in the x-axis. And then the same goes for the y-axis, but with a y offset and just modulo 5 because we have 5 LEDs in the y-axis on the shades. So the reason this works is that we have these two arrays outside the function, so they are initialized once and then never again, which means that we can change their value and it will be persistent over the iterations of the effect. And it may seem that we just change it in this scrolling function or scroller function, but actually since we pass these as pointers, this isn't we actually work on the same data as these up here. If we take this variable right here, array length, which comes from number of LEDs down here, this value will be a copy of this value, and that is called call by value. So you, instead of working on the same data, you just copy the data and work on the copy. So that means that if I were to change rlen in this function in here, number of LEDs out here would not be affected, but because we pass these as references, that is called call by reference. As we pass these by reference through a pointer, we're actually telling the program to go find that same piece of memory and work on that. So position 0 in x LED in this scroller right here, in this scroller function, is the same as position 0 in the x LED we send in here, so that is the 2 here. Which means that when we add something or subtract something with the x off integer, that means that the value right here is actually updated. So that means that the shape will be scrolling in some direction. I hope that's clear, otherwise ask in the comments and I'll try to clarify. So how this looks is I've actually uploaded this to my shades. it may look a bit weird because I'm having it scrolling diagonally just to prove that, or just to show that it does scroll in both X and Y axis at the same time. So it may look a bit weird, but it's the principle. So down here you see it should scroll 1 pixel or 1 LED each iteration in X-axis and 1 in Y-axis as well. And that looks like this. Can you actually see that? It's a bit bright, isn't it? Let's see here. I'm just gonna tone down the brightness. Well, it's a bit unclear, I guess, but you can see that the shape is scrolling regardless. So, not that much code, and you can, it's just, what is it, like 6 rows? Yeah, 6 rows with these curly braces down here. And that piece of code can actually scroll any shape as long as you define the shapes using 2 arrays of positions, one in the coordinates in the x-axis and one of the coordinates in the y-axis. And if I want to have 2 shapes scrolling on the same effect, for example, I have 2 hearts, one on each eye of the shades, I suppose. If I wanted to have them scrolling separately at different speeds or in different directions, I could do that by just cutting off like this. I'm not going to upload that because it takes time. Let's see here. Whoops. So now I have the y-axis for one heart up here and the y-axis for the other heart down here. And then I could just do the same for the x-axis. There we go. And then copy this, put it down here, and change the direction or the speed. So I want -1 here, for example. This will now, if I upload this, it will scroll not from the top down as it does here, and which is the effect which I uploaded to my shades, but it will actually scroll from the bottom up. So that works as well. I just have to call this function twice with different values and have different arrays for the 2 different effects I want to scroll on the same effect. So I hope that's clear. I'll upload the code to my GitHub as usual and link in the description to that repo. And if you have any questions, just throw it at me in the comments. I'll try to ask and I'll try to answer as best I can. And well, I guess that's it. Thanks for watching, guys. Hit me up with a subscription if you want to see more of this kind of stuff. Yeah, and I guess I'll see you next time, so have a good one, guys. Bye.